So we'll continue looking at more concepts, and today we're going to be looking at molar volumes of gases. And you can go on page 16 so that it can be easy for you to follow through. So the Avogadro's law states that equal volumes of molar gases under the same conditions of temperature and pressure contain equal numbers of molecules. When we compare the volumes of gases, we must keep their temperatures and pressure the same. The molar volume is the volume occupied by 1 mole of gas. So the first thing that we must take note is that the molar volume is the volume occupied by 1 mole of gas. So we can write down that point. So you can say the molar volume is the volume occupied by 1 mole of gas. Then the molar volume, we can say the molar volume is represented by this symbol. So we are going to have a V there and M. So that's the representation of the molar volume. So the molar volume of a gas is the volume that it occupies at some standard temperature and pressure, or at room temperature and pressure. So the molar volume of gas is the volume that it occupies at some standard temperature and pressure, or at room temperature and pressure. So it's the amount that is occupied at standard temperature and pressure. So the standard temperature and pressure is represented by STP, or at room temperature and pressure. So, or at room temperature and pressure. And that is represented as RTP. So we can say that the molar volume at STP, which is standard temperature and pressure, so our molar volume at STP is 22.4 cubic decimeters. Then that at room temperature and at RTP is 24 cubic decimeters. So you must know 22.4 cubic decimeters as that of standard temperature and pressure, and as that of room temperature and pressure as 24 cubic decimeters. So to calculate the volume of gas at standard temperature or at room temperature and pressure, we use this formula. So the formula that we use when calculating volume, we say that V is equal to N multiplied by Vm. So we can say where N there, as you can see, we have N there, represents mole of gas. So we can say mole of gas, and the symbol of mole, we have that. Then Vm there represents molar volume of gas. So Vm represents the molar volume of gas. And the molar volume of gas, we have said it can either be 22.4 cubic decimeters at standard temperature and pressure, or it can be 24 cubic decimeters at room temperature and pressure. Then V, the one that we are calculating, V there represents the actual volume of gas. So we have actual volume of gas, and the symbol there is cubic decimeters. So before we look at the questions, we have to take into consideration the conversions of volume units. So our volume units, the ones that we use when we are trying to convert cubic centimeters to cubic decimeters. So we can say that our 1000 cubic centimeters is equal to 1 cubic decimeter, and there we can say 1 liter is equal to 1 cubic decimeter. So for example, if you have been given 2000 cubic centimeters, converting it to decimeters there, that's going to be 2 decimeters. So you just use these equations that I've given you to convert cubic centimeters into cubic decimeters, or cubic decimeters into cubic centimeters. Let us now look at the questions. So our first question there, we have, what volume does 0.25 mole of carbon dioxide gas occupy at room temperature and pressure? So what volume does 0.25 mole of carbon dioxide gas occupy at room temperature and pressure? So the first thing that we are supposed to do there is to collect our data. So we know that our molar volume there, it's 24 cubic centimeters, since we have been told that at room temperature and pressure. Then the number of moles we have also been given as 0.25 mole. So we are going to write it down. So 0.25 mole. Then we have been told to calculate the volume. So the volume we don't know. And we know that the formula of volume is equals to number of moles multiplied by the molar volume. So volume is equal to number of moles, we have 0.25. So we're going to write 0.25 there, multiplied by the molar volume at room temperature and pressure, we have 24. So our volume there is going to be equal to 0.25 multiplied by 24. We are going to have 6 cubic decimeters. So that's going to be our answer. Question 2 reads, what is the volume of 0.1 mole of oxygen gas at standard temperature and pressure? The first thing that we're supposed to do there is collect our data. So we have been given as number of moles, we have been given as 0.1 mole. So 0.1 mole. Then the other thing that we have been given there, we have been told that it is standard temperature and pressure. So we can say that our molar volume is equal to 22.4 cubic decimeters. So we're supposed to calculate our volume. So we don't know our volume there. So we're going to say volume is equal to number of moles multiplied by molar volume. So the volume there is equal to number of moles, we have 0.1 multiplied by the molar volume, it's 22.4. So volume there is going to be equal to 0.1 multiplied by 22.4. We are going to have 2.24 cubic decimeters. Question 3 reads, what is the volume of 4 grams of hydrogen gas at room temperature and pressure? So what is the volume of 4 grams of hydrogen gas at room temperature and pressure? So as you can see in the question, we have not been given the number of moles. So the first thing that we're supposed to do is to calculate the number of moles. Then after calculating the number of moles, we can calculate volume. So let us first write down the data that we have been given. So for the data that we have been given, we know that mass have been given as 4 grams. Then we can say that our molar mass of hydrogen gas, we have been told that's hydrogen gas, and we know that the number of moles there, we have 2 multiplied by the mass number of hydrogen is 1, so that's going to be 2 gram per mole. So our molar mass there, we're going to have 2 gram per mole. Then we know that our molar volume there, it's 24 cubic decimeters, since we've been told is that room temperature and pressure. So the number of moles there, we don't know, and the volume there, we don't know. So the first thing that we're supposed to do is to calculate the number of moles. So we can say that number of moles is equal to mass divided by the molar mass. So number of moles is equals to mass. The mass we have been given as 4 there. Then divided by the molar mass, it's 2. So the number of moles there, we're going to have 2 more. That's going to be the number of moles. Since we know the number of moles, we can now calculate volume. So we say volume is equals to number of mole multiplied by the molar volume. So volume is equals to 2 multiplied by the molar volume, it's 24. So volume is equal to 48 cubic decimeters. So that's going to be our answer. Question 4 reads, what is the mass of 72,000 cubic centimeters of oxygen gas measured at standard temperature and pressure? So the first step that we're supposed to do there is to calculate the number of moles, and after calculating the number of moles, we can now calculate our mass. So let us write down our data, so the information that we have been given. So we have been given volume as 72,000 cubic centimeters. Since volume have been given in cubic centimeters, we need to convert it into decimeters, and we know that 1000 cubic centimeters is equal to 1 cubic decimeter. So we're going to say, what about 72,000 cubic centimeters there? It's going to be equal to x. So we're going to have 1000 x is equal to 72,000. So divide by 1000, divide by 1000. So our x there is going to be equal to 72 cubic decimeters. So converting that into cubic decimeters, we're going to have 72 cubic decimeters. Then the other information that we know is that our molar volume is at standard temperature and pressure, and that's going to be 22.4 decimeters. Then our molar mass is going to be equal to 32 gram per mole. And how we calculate the 2 gram per mole, we know that we've been given as oxygen gas there. So oxygen gas is O and the 2 there. So we have 2 atoms multiplied by the mass number of oxygen is 16. So our answer there is going to be 32 gram per mole. So that's how we get that. Then the number of moles we don't have. Then the mass we also don't have. So the first thing that I've said is to calculate the number of moles, and we know that our volume is equal to number of moles multiplied by the molar volume. So to calculate the number of moles there, we're going to divide by molar volume, divide by molar volume. So the formula for number of moles, we can say number of moles there is going to be equal to volume divided by the molar volume. So number of moles is equal to volume. Volume have been given as 72 cubic decimeters. So we have 72 cubic centimeters decimeters divided by the molar volume there, it's 22.4. So we are going to say 22.4. So the number of moles is equal to, so 72 divided by 22.4, we are going to have 3.214 mole. So we know the number of moles as 3.214 mole. We can now calculate our mass. So mass is equal to number of moles multiplied by the molar mass. So we say mass is equal to number of moles we have calculated as 3.214. So we're going to write it down as 3.214 multiplied by the molar mass. The molar mass is 32. So we're going to have 32. Our mass there is going to be equal to 102.848 grams. So that's going to be our answer. Question 5 reads, a gas cylinder has a capacity of 125 cubic centimeters. Calculate the moles of carbon dioxide gas that can fully occupy it at room temperature and pressure. So we're going to say we're going to collect our data there, and the data that we have, we're going to say the volume have been given as 125 cubic centimeters, and converting it into decimeters, we're going to have 0.125 cubic decimeters. Then we know that our molar volume, the molar volume there, we've been told that it's at room temperature and pressure, so that's going to be 24 cubic decimeters. Then the number of moles, we've been told to calculate the number of moles, we don't know. So we can say that our formula for volume, we know that volume is supposed to be number of moles multiplied by the molar volume. So you can say number of moles is equal to volume divided by molar volume. So number of moles is equal to the volume there we have been given as 0.125. Then the molar volume at room temperature and pressure, we know that's 24. So the number of moles is equal to 0.125 divided by 24. We're going to have 0.0052 moles. So that's going to be our answer. Then B, we have the mass of carbon dioxide gas that can fully occupy it at standard temperature and pressure. The first thing is to write down the data. So we know that volume is equal to 0.125 cubic decimeters. Then we know that our molar volume, we've been told that standard temperature and pressure, and we know that's 22.4 cubic decimeters. Then the molar mass, there we can calculate for carbon dioxide gas. So we have our CO2 there. So there we have carbon. We know that the mass number of carbon, that's 12. Then we also have oxygen there. So we have 2 atoms of oxygen multiplied by then the mass number of oxygen, that's 16. So we're going to have 12 plus 2 multiplied by 16, that's 32. So 12 plus 32, we're going to have 44 gram per mole. So our molar mass there is going to be 44 gram per mole. Then the number of moles we had, the number of moles we also don't have. So the first thing that we're supposed to do is to calculate the number of moles. So to calculate the number of moles, we're going to say number of moles is equal to volume divided by the molar volume. So number of moles is equal to volume we have been given as 0.125 divided by the molar volume there, it's 22.4 at standard temperature and pressure. So the number of moles is equal to, we're going to have 0.0056 mole. So to calculate our mass there, we can say mass is equal to number of mole multiplied by the molar mass. So mass is equal to, I've calculated the number of moles there as 0.0056 multiplied by the molar mass there. Molar mass we had calculated as 44. So when we multiply those two numbers, we're going to have 0.25 grams. So that's going to be our answer. So question 6 reads, calculate the number of atoms of helium gas at room temperature and pressure if the gas occupies a volume of 40 cubic decimeters. So the first thing that we're going to do is to collect the data. So we're being told to calculate the number of atoms, which is also known as the number of particles. So we can say our volume have been given as 40 cubic decimeters. Then the other information that we have been given there, we know that our molar volume, we have been told that it's at room temperature and pressure, so that's going to be 24 cubic decimeters. Then we are trying to calculate the number of atoms or the number of particles there, and we know that for the Avogadro's number is given as 6.02 multiplied by 10 to the power 23. Then the number of moles there we don't know. We also don't know the number of particles. And we know that the formula we had said earlier that the formula of calculating number of particle there is the number of particle is equal to number of moles multiplied by the Avogadro's number, or the Avogadro's constant. So our first thing there is supposed to calculate the number of moles, and we can calculate the number of moles from the formula of volume. So we can say number of moles is equal to volume divided by the molecular volume there. So number of mole is equal to volume, we know that's 40 divided by the molar volume. Molar volume at room temperature and pressure, that's 24. So number of mole is equal to 40 divided by 24, that's 1.67 mole. Then from there we can calculate our number of particles. So the number of particles is equal to number of mole multiplied by the Avogadro's constant. So the number of particles there is going to be equal to 1.67 multiplied by 6.02 multiplied by 10 to the power 23. So our number of particles is going to be equal to, our answer there is going to be 1.00534 multiplied by 10 to the power 24. So that's going to be our answer. So that's all about the molar volumes of gases. So the most important thing that you must take note when calculating the molar volume of gases is to use the formula of volume is equal to number of moles multiplied by the molar volume. And you know that the molar volume can either be at standard temperature and pressure, which is 22.4 cubic decimeters, or at room temperature and pressure, which is given as 24 cubic decimeters. So if you have any questions, please ask in the group.